Okay, so everyone, I'm going to go over a bunch of stuff that I think each one of it's been mentioned in some way, so I'll try to focus on adding some of the extra context. My general message to convey is that the TEs are the most important tool for realizing decentralization in the upcoming era of Web3. It's kind of counterintuitive because taking on trusted hardware as an assumption seems like a centralizing thing to do at the infra level, but in terms of the user empowerment it unlocks at the application level, that's what makes it way more important. If you only take away one concept for how to think in this design space, I think looking for ways that using TEs you can find and unlock hidden complementarity, especially in sensitive data, that's really a way of describing some of the coolest things that this brings. And in general, I think the effort is using TEs to bring permissionless composition, not just to Web3, but also to Web2. And thinking of Web2 accounts as resources is, I think, a new perspective. So that's what I enjoy talking about the most. The track today has been so good, I definitely don't need to do any context background, so I can skip over it. But TEs provide two features for us: isolation against even the owner of the TE or any account admins on the machine, and remote attestation. And that's why they're so great for disintermediating. You don't need to take an app developer's word for it that they're providing a service they say they are. You can check the bill of materials from Intel directly. Don't have to trust the cloud, don't have to trust the app developers, do have to trust the manufacturer for now, but that's the open area to improve on. The simplest mental model for the experience of building things with TEs. If you accept Georges's framework, then this makes sense if you consider yourself on one of the level 3 stacks or better, like the confidential virtual machines, because it says you can take practically any source code that wasn't made for TEs and run it in a TE as though it were a black box transformer, and you get a free upgrade. If you run smart contract systems, you get programmable privacy. If you put DeFi gadgets in there, you get dark pools and privacy versions of those DeFi gadgets. If you put in MEV infra, then you get MEV infra that has receipts that it actually followed the rules it says and didn't peek at the bids. General, if you put blockchain infra tech into a TE, then you get some of the additional security properties that you might not have otherwise had added by the TE just by putting them through this transformation. And it doesn't just stop at Web3. If you put in PHP and MySQL web services, then you get decentralizable versions of those, so decentralized front ends in general. And you get then Web3 compatible handling of any of the accounts and passwords that are stored in such databases. And so that's how this can bring permissionless composition. I'll be saying a bit more about this in a moment. So the examples that I'll go over just put onto this little schematic. So if you put account credentials, like the Twitter accounts, inside trusted hardware, then what you get back are basically fine-grained delegation. You can apply smart contracts now to the right to tweet, which would have otherwise been a Web2 resource outside the world of smart contracts. Now it's inside the world of smart contracts. You don't just have to stop about putting the ability to tweet, you can put an entire account, the root credentials inside TE. Now, smart contracts can have exclusive ownership of that. You can do more credible things. And the last example that I'll go over in more a little bit is you could put AI agents inside of a trusted hardware. Maybe you've seen Truth Terminal. It's like a edgy Twitter bot that claims to control its own account, but you can never be sure. It kind of seems like there's humans that are meddling in it. But if you put the agent in a TE, then it gets upgraded with essentially using the TE to guarantee that it's doing what it claims to do in the first place. I will go over in a little more detail a couple of these and then wrap up. The starting point I like to describe as the overdelegation problem in Twitter. So being able to tweet from others people's accounts is not new. That's what you get with third-party delegation, like through the OAuth protocol. But you kind of only have two choices. There's read-only delegation and read-write delegation, but that comes with change your profile photo, delete tweets, and it's not just post once, but post indefinitely. So there is support for delegation in Web2 today, but it's extremely coarse-grained. There's nothing in between sharing not enough and sharing too much. So the way Teleport works is that you get to create a one-time use only delegation. You can set a filter that has to be passed before the person claiming this can post to your account. You get a code that you could just hand out and pass like a URL. And then whoever has it can try to tweet from your account. If they pass the filter, then only one time, then it makes a transaction for write once on the blockchain, and then only then does the enclave with the account credentials carry out the tweet. So it's a URL that you can paste, but it's also an NFT. So this transaction is actually creating a minted transaction. And since it's an NFT compatible, protocol compatible thing, it automatically shows up on OpenSea, which means OpenSea provides a secondary marketplace for the ability to tweet in limited ways from participating accounts. And so just seeing this transformation is something that you don't ordinarily think of as a Web3 digital asset resource, which is Web2 account abilities. Now, when you think of them as smart contracts, you can do much more. You can think of them as digital assets and things of values. So the first example of complementarity is doing flash mobs with this. So because they are NFTs, you can package the NFTs into a single contract. So like a bundled derivative of the rights to post from Twitter accounts. And then there's something whole better than the sum of its parts that shows up here, because the ability to tweet from a whole bunch of accounts at once is qualitatively different and can be more powerful than just tweeting once at a time. You can play poker or give people the right to tweet once from your account, either as like an exchange or a kind of tipping action. It's interesting because these sort of occupy some space that's not quite money, but still something of value. And that's a cool space for the crypto world to play in. So to describe this in terms of permissionless extensibility, this teleport demo already exhibits 3 kinds of permissionless extensions. So not all rights to tweet are the same. The fact that you can specify your own filter means that you can put different games. Like you can say it either has to be message A or message B, and let whoever has the token pick where you're going for lunch, for example. So that's user customizable. We covered the way the smart contracts are there. I think the last thing I'll say on teleport here is that it supports bring your own front end. There's no official front end for teleport, which means that you can in principle make your own third-party front end. It basically has a split trust model where only the backend portion that handles the minting and redeeming and holds the account credentials is in the TE, but the front end is outside the TE, not because it can't fit in the TE. It could, it could be a TE front end too, but because this way it's explicit that you can bring your own front end and add more functionality that way. For time, I will skip some of the other details of this, and you've heard a lot about the supply chain, so I'll just go into all right, next topic. So I gave this slight background about Truth Terminal. Maybe I'll just go straight to then explaining what it looks like to put a bot in a T, and I'll say a bit about DStack in a moment. So we have this Twitter bot that exhibits full control over its own accounts and can show what code it's running. So in this deployment, the TE consists of the agent code for this bot, so all of that is public. The TE then also manages the private account credentials to its wallet and to its Twitter account. The entire functionality is not public, so it's basically specified up to a template where some private prompt examples go. So you can put in your own prompt examples to understand the flow of the agent. So this is an example of proprietary sandboxing for portions of a TE app. The whole thing is, as most, I think, interesting TE applications are, it is kind of following the smart contract. That's what imposes restrictions on how this code can be updated. And the whole point of this is to be able to show that even the human admin who's running this thing isn't able to inject their own messages or bias it or change what it runs. It actually has to be running according to the rules that it says. And then, yeah, I'll mention about this. Also, there's snacks grid inside the TE. The main thing that I'll then go on and maybe skip the rest of these for time is that this bot can show that it is the only owner of its Twitter account. Any of the tweets made by this bot are made by the bot and not made by a human who also has access to it. And the way that this works is that the human admin loads up the agent with a password, but then it generates its own random password that it wants. And it uses password 1, which it has, to actually log into its Twitter account and change the password to the random one that it only knows. Now, Twitter has a mandatory recovery email, so it's not enough just to change the Twitter password. You also have to have an email account, and you have to do the same thing for the email account. The bot learns it, logs into the email, then changes the email account to a password only it knows. And it also has to go through another endpoint on Twitter to kick out anyone else who has a session. So it logs out of the Twitter account. Basically, this bot completely takes over exclusive control of the email account, kicking everyone else out, and then being able to provide a remote attestation that this is what happens. This is how you show that the bot has exclusive ownership of its accounts. I'll skip other things about the bot and just reiterate some of what you saw from the DStack demo. So this bot proudly lives on a multi-operator cluster of DStack instances. So what DStack is giving you is there's a singular base VM image, which just takes care of handling TDX attestations and providing a Docker container driver. And so you can define more varied applications that all use the same base image by just defining a Docker container. And there's lots of different approaches to making application containers reproducible and auditable. And what's really appealing about this also, I would say DStack is the thing that has taken us from the level 3 to the level 4, at least in the developer experience and in Georgios's framework. This is pretty quick to rapid iterate and deploy. Basically, the application containers, when run in this DStack image, really behave exactly the same as ones run outside of it. But you don't even have to take that because the base VM image itself can run in QEMU outside of the TDX environment. The mock attestations are really the only things that have to get mocked out at all. So you can run both the real container and both the real container in the real VM image, all just on a laptop without TDX, either of those options. So it's a pretty convenient framework. And then the rest of the technical details, which I'll skip, but maybe you can imagine how it goes. You want to be able to have multi backups, so you need to be able to copy private state from one node to the backup. You still need to do this without any human seeing it. So this is basically orchestrating such a migration using the smart contracts to document and constrain it, and using the remote attestation checks so that it's provably followed out according to that plan. Okay, I'll wrap up with two short frameworks. So the first one is just to point out, because now we've seen demos of both TDX and SGX, and basically I would say these still remain important. And the reason why is that across all the different applications, this isn't exhaustive, just the ones that I've been tracking, they have different needs from the underlying platform. Maybe we'll all just have DStack able to provide good answers for all of these simultaneously, but for sure in the interim, even SGX and different CVM frameworks have different trade-offs here. So basically not all apps require the same high performance. Like an L1 or L2 builder is probably on the very far side of performance requirements. Something like Teleport is actually way lightweight in terms of the performance that it requires. The other features that are most demanding of the framework are whether it supports contestable applications. Like in DStack so far, it's still, DStack is kind of crossing over to smart contract controlled clusters, but at least for now, it's admin controlled. If you contrast that with any of the TEE smart contract platforms, those already have the quality that you can, it's censorship resistant publishing, so you can't be stopped from deploying a new application. That's just deploying a smart contract. I won't, that's enough to give you a flavor of this, and you'll be able to see the slides. I will skip to then just the last framework, and then I think wrap up for time. So one way of summarizing the design space that's been explored by these examples is that you know that you can do anything in smart contracts with Web3. So that's the top row of this. And we now can think of things that you can do with Web2 accounts that aren't just Web3. And there's different actions that you can do on these as well. So this read column, maybe for all of the different accounts, covers what you can do with any of the forms of ZK-TLS. All of the different action types besides read, those you can control with smart contracts. We already needed to do that with Web3. So it's like the first column and the first row were already filled out. But now with this new viewpoint, the whole bottom right rest of the table becomes kind of available. So you can view Teleport as something that takes read actions from Web3, so the NFT events for redeeming, and it translates them into a write on a Twitter account. And then you can see how you can attach these other kinds of concepts. I gave that kind of story about how a flash mob is a form of complementarity whole better than the sum of its parts, but you can bundle all of those together in a smart contract once you bring these new resources into Web3, where you can do that. The ability to not just productively use an account, but also just to threaten to lock you out of an account for a while is like slashing, but for Web2 accounts. That means you can bring the magic of restaking, based on Web2 accounts. You might imagine being able to stake in Web3 based on them. Yeah, I think that I'll leave off with the one last comment, which is that, especially reflecting on the different frameworks here and the rapid understanding that we've gone to, something that appeals about TEEs in general, that I think also about especially the encumbered accounts, is that you really don't need a huge network effect to get some value out of this, right? And this also means that these are very robust in terms of design areas. Like, you don't need to attach to an extremely large platform in order to be able to do something useful, putting your own accounts into a TEE and giving a remote attestation that shows an audit log of how you've used those account credentials. So I think that there's a good opportunity here to be extremely pluralistic, which I think is how our ecosystem is developing here. You can make the barriers to entry as a core developer quite low for these kinds of things. So we may not need to only just have a single software framework that abstracts over everything. Still, we should be making DevX improvements and keeping the audit surface low. So, okay, I'll stop there. Thank you.